Very happy for you to join our May IPFS meetup. Love to know where you tuning from. What are you drinking? I'm currently in Lisbon, Portugal. Pretty sunny. You might see the lighting changing throughout the meetup because the sunset will be coming pretty soon. And I'm having some water. Hi, Molly. We have 3 amazing presentations today. Having some tea, amazing. I wish I was having some tea as well. Lovely. Air conditioning is very important. We don't have that here in Portugal, sadly. Okay. Hi, Wayne. Oh, England. I also live in London, and then COVID happened, so I decided to come to a pretty sunnier place. All right, so we already have some Barcelona, Berlin. Amazing. Well, I'm really happy you're here. Really happy to have you. I'm not too sure what 66 is in Celsius, but okay. So I think we're ready to start the meetup. Really happy to have you here. So a few reminders. This event abides by the IPFS Community Code of Conduct. You'll be able to find more about it in the chat. Please ask all the questions in the chat. Look at on the right-hand side of your screen. The speakers will be able, and the team will be able to answer all the questions there. If you like to watch our past events, or actually if you'd like to watch this event again, it will be available on IPFS YouTube page. Will also be linked below. And if you're interested in speaking our future IPFS meetup, you can email us as well. We'd love to have you and to know more about the project you're working on. And for today, we have 3 amazing presentations. We have Chris and Mohammed from Almonite telling us more about LPress, a self-governing ENS plus IPFS publication platform. Secondly, we have Yanis from PL telling us more about ResNet Labs, as well as decentralizing the internet with IPFS and Filecoin workshop. Very exciting. And to finish off, we have Wayne telling us more about Kepler, Orbits, and permissioning and identity. Very excited for all these 3 talks. And if Mohammed and Chris are ready, I will let them start.
I think we are ready. Please share the screen with you. Please let me know if you can see the screen.
Yes, you can. You have a pretty...
Hello? Can you see my screen now?
Yes, your connection is a bit weak, but we can.
Okay, good. Well, I hope you hear me okay. So hello, everyone. Welcome to Almonite presentation. Almonite decentralizing the web. So basically, to you, if you think who we are a group of friends working together, developing projects that can change internet for better. And what we mean for better means we aim to decentralize to some extent web, bringing some values such as increased privacy, increased censorship resistant content, and provide, via IPFS, ENS, better quality tech. So my name is
Chris, I think we've lost you. Mohammed, are you able to take over instead and handle the presentation? Or we can skip over to have you, Yana, start first and
I think Chris connected again. I will just suggest him to close his videos as well, so it may work for him.
okay, why don't we, Giannis, if you're able to present, and then we can have, oh, Chris is back. Are you?
Yeah, absolutely, I can do it.
Okay.
Hi, sorry, have I been disconnected?
Yeah, your connection is very weak.
Okay.
We can't really hear you. So I think we'll just move on to Giannis right now. And if you want to try to figure that out, we can come to you second.
Okay. Sounds good. Thank you.
Thank you.
Okay, hello everyone. Let me start then. And I'm going to start with this great magic bus, which is a bus that took us on a wild tour during late 2019 and 2020. And the ResNet Lab members, the Resilient Networks Lab members from Protocol Labs, we've been to several different conferences and events where we presented the Web3 stack, talked about IPFS, libp2p, and all this great work that is happening in this community. We talked to thousands of academics and PhD students and researchers. We presented more than 3 hours worth of tutorials in every event that we've been at. And as we were going on, we figured out that we can do something better, which can reach out to many more members of the community. So what we did was that we have put this very nice website together, and which has got a number of different modules. It starts with some core modules, which you can find here. It talks about content addressing, content routing, content exchange, and mutable content. These are all 20 to 30-minute tutorials, which you can find on this page. There are several, lots of resources around for each module. You can find related links. You can find a list of our open problems where we're looking for other community members and researchers and university labs, but not only, to come and work with us to solve these problems. So there are lots of links here. You can also find the slides of every module, which you're free to download and reuse if you are organizing a lecture or a meetup or any related event. You feel free to get the slides and reuse them. And we are going to have more coming. So we have the core modules that talk about the core of the IPFS and the Web3 stack. But we're going to go a step further and talk about more in depth about some of the parts of those stacks. So we already have one elective module on Leap P2P, which was released last week. And next week, we're going to release one more on IPLD, the interplanetary link data. And we have more that is going to cover Filecoin, other protocols, PubSub and GossipSub, and many more. So stay tuned. What you can also find is a list of the blog posts that we've written after every event we've been at, which is a great resource because we are answering there all the questions and answers that we get from the audience. And it's great to follow up. There is lots of material there that you can find out about IPFS and every module that we're basically presenting. So this is just a snapshot of the places that where we've been, and we're populating it as we go along. You can there is a form if you want to get in touch and invite us or others in the community to come and present those modules to your audience. And there is a GitHub discussion repository where you can start discussions, ask more questions, make suggestions, and so on. I'll post all those links in the chat afterwards. For now, I would like to jump to the second part. I come as a two-in-one, so I'm going to be presenting two things in one slot. So that's the second one. We are organizing a workshop alongside a big conference in computer networks, which is called IFIP Networking. It's hosted by IFIP. And the title of the workshop is Decentralizing the Internet with IPFS and Filecoin. It takes place on the 21st of June 2021, and there are going to be several interesting topics covered. We have 8 paper presentations. There is going to be some abstracts and demos, but also apart from that, it's going to be some less traditional kind of sessions that we're going to include in this workshop. There is going to be a hands-on session. You can actually see the workshop program here on the conference's website. It's going to start at 11:15 UTC +3 on June 21st, and we're going to start with a hands-on session where all the participants are going to get their hands dirty with IPFS. We're still putting the program together for the hands-on session, and we're going to release details very soon. So if you're interested, just sign up and register here at the conference's registration page so that you receive all the updates. We're going to have an exciting keynote by Thibault at Cloudflare, where we're going to see how Cloudflare is building CDN scale infrastructure with their gateways and all the other nodes that they host at Cloudflare. This is going to be a very interesting talk. And then we're going to have 3 sessions. We're going to cover several things from protocol and architecture extensions for the DHT, for PubSub protocols, and so on. There's going to be some demos from several people in the community. And then as a third session, we're going to talk about more like other services, Web3 services and decentralized identities. There are very interesting topics, as you see here. They're going to be covered, how we can run Solid over IPFS, decentralized identifiers for peer-to-peer service discovery, and so on. And finally, we're going to close the workshop with announcing a hackathon, which is going to run from that day onwards. Of course, after the event, it's going to last for a couple of weeks. There are going to be prizes. The details, again, are not set in stone yet, but they are going to be in the next couple of weeks. So stay in touch, register in order to receive all the updates, and get in touch if you have any questions. Thank you very much. That's me.
Thank you so much, Yanis. Please post all the links and anything that you have in the chat. I'm sure people will love to check it out and see what you've been working on and planning for the future. Chris and Mohammed, how's your connection?
Hi, I think it's much better now. Can you hear me properly now?
Yes.
Yes,
Sounding
okay.
great.
I'm going to share the screen with you now, and you can then perhaps advise me if you see it properly.
Yes, I
Yeah.
can.
Good. So hello, everyone. My apologies for the connection problems prior on a previous opportunity. So welcome everyone to Almonit. Almonit, just going to quickly tell you what it does, and what we do, who we are, and the presentation is divided into two parts. One, I'm going to be talking about the non-technical parts of it, and the second part, which will be covered, will be by Mohammed. He will talk about more technical details, but as well give you a demo of the Alpress platform itself. So who we are a group of people, a group of friends working together, developing projects that plan to change the internet for better. So what we mean by that, it means we try to decentralize a piece of internet, bringing a little bit more value in the censorship resistant areas, privacies, as well as the robustness of the technologies that lays behind the IPFS or ENS. So you can see that my name is Christopher Lebos, and I'm a co-founder as well as a lead operation. Mohammed is another co-founder as well, and he is our technical lead. So what exactly is Almonit? Almonit is a project for developing decentralized web applications and web services as an alternative to traditional tools functioning today. So now let me give you a quick brief in terms of what sort of projects we have already developed on Almonit. So at the moment we have ENS Resolver. It's an extension that is fully decentralized, it's censorship resistant, it is anonymous, it doesn't have a central authority, and supports all modern browsers on Chromium based. So basically, it is just a link to the decentralized web. The other tool that we also thought it's important for us once we created the extension, it was if we create a decentralized a search engine that will help discover all the decentralized websites. As you can see, there is if you go to almonit.eth.link, the first thing what you see is actually a decentralized website itself, and it's our search engine. It is just a basic version of the search engine. It works quite okay, but we haven't spent so much time on it only because we realized how important for us actually is to create another tool that actually will help all users across the globe to easily access the decentralized web, but also help them create decentralized websites. So we thought the next step for us really is to create a decentralized platform. And here it is, Alpress. We decided to call it Alpress. Alpress is a self-governing decentralized platform for publishing articles. What actually the Alpress 2 is gives you a possibility to to use the built-in rich text editor, play with the text, implement, add some pictures, and just work exactly the same as any other blog platform. There is a couple of examples here. You can see that how it looks like on the left side, but it also shows how the published article can look like. So in a nutshell, there is a couple of things that can be described by the Alpress. Alpress is self-governed, and that means contributors are the members who decide what exactly is happening with the content that is being created within the Alpress community. It is also decentralized, so that means there is no single point involved. It is also censorship resistant. No one can censor the content apart from its members. And what most important, there's no technicality needed in order to use it. So no developer skills. And anyone can really go in and just create a decentralized website in a few and easy steps. Now let me dive in a couple of more details in terms of those four points. So self-governed organization, what exactly it means? It means it's an alternative to today's commercial control mechanism. Okay. Sorry, just a second. So what exactly Alpres is offering? Alpres is offering, it combines 3 different technologies. One technology behind it is IPFS for storage services, but also ENS for the domains, but also as well the DAO. And the DAO in this case is actually presented as a SGO. So ENS and IPFS technologies are the core technologies behind the Alpres project. Censorship resistance is actually another powerful tool that is being utilized. And Alpres is decentralized to the extent ENS and IPFS technologies are decentralized. So no one can really censor the content of Alpres apart from their members voting via DAO. And DAO can be voted within 2 different models, either voted by the community or by the appointed members. What most important as well is that anyone can use it, and it's really so easy to create an account within the Alpres. All you need is just quick access to the MetaMask via the MetaMask wallet in order to complete a couple of simple transactions. And the registration process is really, really easy. Now, I would like to ask my fellow friend Mohammed to give you a demo how actually the Alpres looks like and how it feels. Thank you.
Sure. So, all right, I'm sharing my screen for the demoing. I assume you already see it, right?
Yes, we can.
Ah, cool. So let me again express what is Alpres one more time, as my friend Chris did. So Alpres is a decentralized self-governing publication platform. Anyone can be an author and publish their articles in the system, and users can be anonymous while doing that. And any reader can reach those articles and read them without having an account. Alpres consists of 2 main parts. The first one is a decentralized web application based on ENS and IPFS, as you see in here. It actually comes from IPFS gateway. And the second part is the DAO. It stands for Decentralized Autonomous Organization. So it's like a sort of a decentralized business model, and lets users of Alpres to govern any idea, assets, or decisions by giving them a voting power. And this is the part which transforms Alpres to self-governing organization simply with built-in self-moderation mechanism. And today I will only demo you the web application part. From the point of regular web user, Alpres looks like a traditional web application, as you can see. But the main difference is nothing belongs to the Alpres runs on any centralized server. Means the application requests goes only to IPFS and Ethereum nodes. No analytics, no trackings involved with it. To interact with the application, each user needs just a wallet, and currently, and unfortunately, we only support MetaMask at this stage. And the user needs some test Ethereum, Ether simply for account purchase. And if anyone wants to trade out, I can try to be helpful about that. Login and registration is done over a simple button. If you already have an account, the application will take you to your account, and if not, you will be welcomed with registration wizard. And currently in here, I created 1 account for IPFS, and I have 2 test Ethereum here, and when I click the connect, because I don't have any account, it will just take me here. Each user has a username, as we call it, handle. The handles are the subdomains and the usernames in the platform. It's unique for each user, and every account can have only one handle. Users can reach their profile via handle.alpress.teth or ETH or EDH.link for future. Currently, we are just using ENS on the Rinkaby testnet, so it's not available for public yet. So you can see the if the handle you want to take is already taken by someone or not, like this, by simply querying the blockchain. And if it's not, you can go and buy it. And for this demo, I will buy IPFS21. Here you fill your auto information. Those information doesn't have to be correct. We'll leave it for your needs or to your imagination. I will just call it IPFS, and I will pick your logo. And let's IPFS community. Look, call it like that. And after filling it, we are just signing up, and MetaMask pops up. We just confirm the transaction. It may take some time, and when it's done, we will be signed into our account. Yeah, we are already in our account now, but because we don't have any published articles, we just see one single button to create a new blog post. And now I just want to copy one of the IPFS blog posts into the editor. And I have one in here. This is a built-in rich text editor, so you can do the similar things as you do in any modern like documentation editor. Simply, it lets you do pretty much everything. And let's copy an image. And the content. So you have like both inline tool and separated tool you can use pretty much in anywhere. And now we are ready to publish. And this is our first publication over the press. Soon we want to eliminate these multiple transactions via IPNS. So we don't have to update our ENS content hash each time, because the how it works is simply whenever we publish something, we generate a new content hash and update the ENS with the transactions. We don't want to do that after the registration. And as you can see, this is our first blog. And when I go inside, it's just a regular blog. And this is our profile, simply IPFS21. I'll press that TETH. It may take some time for the first signing process. Yeah, it's interestingly. So it's, yeah, actually, I don't want to take more time. I can share the image later when the profile is signed. So it's pretty much this. Anybody hear me?
Yes. So would you like to
Cool.
share it later? Sorry.
Yeah, I was expecting that it's going to be fast, Sagnik, but
Okay.
seems like it's somehow stuck. Or I can simply, while just sharing my screen, I can show like this for another testing account from today. I can just jump in and open the profile, and at least you can see how it looks like. Yeah. And this is the blog that we shared today. And that's it.
Thank you very much. It looks amazing.
Yeah. Thank you.
Um,
Thank you. Thank you.
Yeah, thank you for presenting. If anyone would like to know more about the project, Chris shared the link in the chat. And yeah, if you have any questions at all. Yeah, Chris, do you want to finish the presentation?
Yes, absolutely. Thank you. So basically, I just wanted to let you know that obviously it's a really, really cool project that's aiming to change quite a bit, you know, and in a nutshell, it is also worth mentioning that the SGO model that is behind the Alpress, you know, it's a new type of organization that operates within the internet boundaries. It is owned and governed by its users. It's an alternative to commercial control of the internet. We could even say that it brings democracy in the internet. And the unique value proposition of that is that it gives back the users the power to decide whatever the matter is to be discussed or published, and not the corporations. So I think this is the kind of big step for us to see if we can actually achieve something about that. Yeah, so this is Alpress. Thank you.
Amazing, thank you. So yeah, feel free to answer any questions in the chat. Amazing, thank you for joining us. So our last speaker for today is Wayne from Spruce Systems to present how Spruce Systems is reimagining trusted interactions through the creation of new identity infrastructure. Wayne, welcome.
Hi, thank you. I'm going to share my slides over in the Zoom chat and then I will share my screen.
Thank you.
So I'm here to talk to you about Kepler. Kepler is a decentralized storage network organized around data overlays called orbits. And it's built using IPFS. It supports many different kinds of storage backends. And the goals of it are to provide permissioning. For example, how do you delete stuff from IPFS today? There's probably a lot of answers that we can figure out, but we want to figure out a pretty canonical way to control that for people who do need to delete things to comply with things like GDPR or the CCPA here in the States. So that means we need some kind of permissioning. Ideally, if it's key-based and also capabilities-based, and I'll get into that in a bit. And the ability to talk about where you actually want the data to live, right? What if you have IPFS nodes everywhere? How do we constrain it to a single country or a single building, maybe your basement, you know? How do we make sure your IoT data can kind of stay in your house and not get eaten up by a cloud provider or something like that, right? What is the way that we can build on top of IPFS to enable this kind of functionality? So some use cases that we've run into, sort of the call to action why we started working on this, is to have decentralized data storage through local consensus, meaning you and your friends can agree to host your NFT images in this shared orbit that you all subscribe to. You all host a copy of each other's NFTs and maybe give each other permissioning to read or write. Or maybe an enterprise can legally bind its partners to an orbit SLA to ensure data availability. Maybe you can build a CDN on this if you pin an orbit to a geography or some kinds of machines, that kind of thing. Maybe a DAO, such as some of the DAOs we saw earlier, which are great ideas, binds orbits to hosting, orbit hosting to crypto economic models such as Filecoin or any others, basically to ensure availability of off-chain content and also make sure that there's consequences if the files aren't there. So what's an orbit? Well, an orbit is something, it's a data overlay defined by an orbit manifest resolved by what we call an orbit identifier. So they can live in a bunch of places. We like smart contracts because it actually solves a lot of the problems, such as if you're setting permissioning, who's the orbit commander, who's in charge here, they can set who can read and write it, and you can actually just use the smart contract itself to gate the access to changing the base permissions. Updatable DHTs, as we see IPFS and IPFS log from the Orbit DB project, not related, it's kind of related to Kepler and Orbits, but a different project. I spoke to the Orbit DB team, and thankfully it seems that they're not too upset that we decided to call Kepler Orbits Orbits, but they are different. But Orbit manifests could live there. They could live as ceramic documents, textile instances, even carry event logs. In the decentralized identity community, there's something called carry, the key event receipt infrastructure, that can also serve this purpose. The idea is that we have a new URL where the hosts are actually defined in a smart contract controlled by the user. So you truly own your data in that you can direct people where to find the host authorized to host your data. And then we use content identifiers, as you might expect in IPFS. So this way, and there's some other information too that define aspects of the orbit, such as what's the base permissioning model, as I mentioned, when we issue capabilities, what's the validity status there, either a certificate revocation list or a cryptographic accumulator can be used. And then content state, what's the latest Merkle root hash of the content, what's our consistency strategy, and what are the authentication methods we support. Here are some example of identifiers. This one is based on the Tezos blockchain, has an account, has a predefined host. You can have implicit parameters as part of the Orbit identifier, so you don't even have to deploy a smart contract if to be able to have some strict defaults. You can also use a smart contract and just source it from there. That's fine too. And then in order to turn a Kepler identifier to a Kepler URL, you either put the identifier as is, or you hash it, and then you can refer to the content identifier. If you hash it, the reason for hashing is to preserve privacy. If you add a nonce or something like that, then presumably someone can change the hash so that an attacker can't discover it unless they have this pre-shared item. It also lets you have sort of a fixed identifier length if you want. This is an example of some of the data that you might find in the Orbit manifest that you resolve from your favorite blockchain, from Ceramic, from Textile, any of these services that support this kind of document update methodology. So you might find out who the Orbit commanders are, who is really in charge of all this stuff, who can read and write, who can delegate those permissions as capabilities, and who can manage the host list. The host list in an Orbit manifest can have a list of a public key derived identifier to IP addresses or even an onion address. Content hash can be the Merkle root, and we might have a revocation state. We need to maintain what capabilities we've issued are valid or not, and we might have consistency strategies. Let's say you don't want to wait for a Merkle root update, you want a faster system running on top of it, maybe Byzantine fault tolerant across all the hosts in the orbit. Well, that it can be specified also with the policy. We separate content and policy. Policy changes being if you want a lot of readers or something, you don't want to store them all in the manifest because it's expensive to store on a layer 1 blockchain. You might want a different consistency strategy for that data. We try to separate policy and content. We also have different authentication methods, including W3C verifiable presentations and blockchain specific ones. We also want to support a bunch of other authentication methods from WebAuthn, FIDO2, blockchain wallet signing. So anytime you can sign something with a blockchain wallet, you can build an authentication method out of that. SSH auth and GBG keys are good. And even looking at some enterprise people who want X509 family of things and mutual TLS, being able to configure these per orbit. So it's really tailored to the use case. These are the different ways that people can identify themselves. They're all key-based, based on public and private key pairs. What's a capability? It's the ability to do something like write to an orbit up to 500 megabytes. Maybe someone wants to give you a file. They're like, how do I give it to you? You can give them a capability and they can write to your orbit within the scope of that capability. Being able to read or write a specific content hash to an orbit, or delegate an ability to someone else to be able to do that. So we wanted capabilities to be pretty, we wanted them to be secure, we wanted them to be expressive, and we wanted them to be pretty useful to people. So we have something called CryptoScript that we're working on that is a statically typed non-Turing complete DSL. We don't like Turing completeness when we're just trying to describe things, and the Bitcoin authors and a bunch of other folks who use reduced languages for security purposes and simplicity, that we took inspiration from them. But being able to check, let's say, an NFT's owner on the blockchain, make sure that it matches with the person authenticating with the request, and then only letting the NFT owner download the content for that NFT, right? That's the kind of permissioning expression that we want to be able to have here. So what does CryptoScript look like? Well, we have some primitives. Let's say that we want to convert a SecP256K1 pub key to a Bitcoin address. There's a pretty deterministic way to do this that a lot of people already know, but being able to express it clearly and then make sure that it's not in a Turing complete language makes it a lot easier to formally verify if you want to, or even compile to implementation in a different language, such as Cryptol or Rust or whatever you like. So you'd be able to push things onto the stack, take the hashes, duplicate things as necessary. This is a fourth and starred stack-based language, but it's not determined if it needs to be stack-based or not. Take a certain number of bytes, concatenate stuff, and encode it with base 58 check. That's how you get a Bitcoin address from a public key of this type. Tezos and Ethereum, pretty similar, even simpler. For Tezos, you might want to take the Blake2B hash, well, you have to, with digest size of 20 of the 825519 key for TC1, and then you encode it as base 58 check. For Ethereum, you would basically take the hash of the SecP256K1 pub key and you drop the first 12 bytes, and then you'd encode it in base 58 check. See, we're basically describing how to get from point A to B in a very crisp and unambiguous way. When you're trying to actually write C and like work with pointers or borrow checkers and Rust, like it can get a little hairy there. So having this pure expression of it is, I think, a very useful way to represent it. But you can also kind of talk to the outside world. In the world of decentralized identity, we have something called the DID method. And this is a form of decentralized identifier resolution where you just query a website over TLS, and you can implement that actually with CryptoScript if you have a few libraries that understand HTTP clients. You might be able to push the expected path past the method-specific identifier, concatenate the two strings, resolve at HTTPS, and presumably the DID module would provide a validation function for you to check if that JSON you fetched was a validated document or not. And to the example I gave before, if you're trying to check the NFT owner to make sure that they're indeed, the NFT owner before you give them access to this really adorable cat picture or something that's large, the original, you might have instructions specific to those assets that consume the asset address, and asset identifier pushes an address onto the stack if and only if successful. And then you might take the VP signer, the verifiable presentation signer, convert that to a public key hash address for a blockchain, and then assert equivalence between the two addresses on the stack. And if you clear it, then you give access. But if you don't clear, then you throw an exception and it's denied. And you might even want to explain to people why you denied them. So we're taking a lot of Bitcoin and blockchain-inspired technology based on the lock-unlock functionality and turning it into something that can cross multiple blockchains and cryptographic systems so that we can specify very clearly, what it is we're trying to check here. And then finally, in the future, we imagine these orbit relationships where you can store a bunch of things into orbits. This is really inspired by FreeBSD's Geom. There's a brilliant article there that I can share in the Zoom after. But if we have two orbits, what if we could have such a copy on write relationship between orbit 1 and 2, where you only have read access to orbit 1, and you want to be able to write to it somehow. So you make an orbit 3 that's copy on write 1 and 2. And all your changes are stored to orbit 2. Orbit 1 stays the same, but when you read orbit 3, it looks like you wrote to orbit 1. Another example of an orbit relationship is being able to compose them. You have a set, a join operation over the orbit 4 and orbit 5, and that's basically what orbit 6 is. You might even have a copy on write over that set that you just made in orbit 6. You might have a specific content hash that you pin the orbit at, and you want to copy on write against that with this new orbit 7, where you would store all your changes. And then finally, we really just rely on content object stores. We don't actually have a concept of metadata like S3 does. You can update S3 metadata in the headers, for example. So for content metadata here, you might be able to specify a metadata companion orbit like this, and it would store the metadata there. You could build an index over the both orbits and have some kind of key value functionality like S3. And then finally, if we have orbit with streaming objects, maybe by default, streaming objects are very bare in Kepler, where you just receive exactly once delivery. And what if you want to replay a bit? You know, you want to see the last 30 seconds of video or something. Well, you might want to add a 4 megabyte stream buffer relationship to another orbit that can store up to 4 megabytes per stream. And then from this, you'd have replay functionality. So that's a bit about orbits. So far, this project didn't exist like a month or two ago, and we've made a lot of headway since. And it's built in Rust on top of IPFS Embed. Thank you, IPFS Embed team. It's been great to use that as a modular toolkit. IPFS RS also looks great too, and they seem very compatible, so I'm impressed at that. And then basically, we have CRUD, create, read, update, delete with blockchain wallet signing, and we drafted this architectural design I just presented. We're working on now permission replication to multiple instances, multiple types of orbit manifests, basically what would look like with IPFS log or an upgradable DHT, multiple authentication methods, so you can use a YubiKey, and then being able to implement CryptoScript in these orbit relationships we're talking about. So that's what we're working on for the rest of the year. One example we have live right now is Tezos profiles. Long story short, you get verifiable credentials that ties your Twitter account to your Tezos address. Where do you store this credential, right? We don't want to store it on chain because we just kind of don't like storing things on chain. It's typically bad for privacy. It's bad for gas costs. It's bad for a lot of reasons. So we store in Kepler, and how it looks is the user signs a request to send the files over to their own personal orbit. And they can, we host the orbit for them, but because it's theirs to control, they can actually promote themselves to a commander and demote us so that we're just a replicator. And that's how we think that users can free themselves and have control over their own data. So that's basically all I have to share about orbits right now. And I thank you for listening. We have a GitHub, it's open source Apache 2. If you want to hear more about how the product's architected, you can read the code, or we have architecture and product requirements documents in the repo if you want to hear about how it's built or the problem space we're trying to solve. And always love to chat about Kepler decentralized identity. DM me on Twitter at WikDD. DD is my favorite Unix tool, a very dangerous one. And then Telegram or LinkedIn, you know, all the cool social networks out there. And I think we have a few minutes left for questions if anyone wants to ask any, but I really appreciate your time. Thanks again.
Thank you so much. It was so cool to see what you're working on. If you could post the links in the chat as well. I don't know if you did it earlier. I think you did the slides. Yeah, it will be great so everyone could check it out. And if anyone has any questions, feel free to ask them and put them in chat. Guess everyone loved your presentation. There was no questions. Great presenter. Okay, so thank you, Wayne. Thank you, everyone, for presenting. Before we finish, I'd like you to invite you to the 2-day hackathon we're running this weekend with Heath Global to build an experiment with NFTs, games, audio, video, and data markets. We'll be giving away over 50K in prizes. Anyone who uses IPFS or Filecoin will be eligible to win Filecoin in the prize pool. And the registration is at web3.ethglobal.co, and you have till Thursday to register. So I hope to see you there. And we're gonna see you next month. We have another amazing meetup planned. You can follow the updates on our Twitter or on YouTube. So yeah, I hope to see you there. Register on meetup.com in advance. And if you're interested in speaking, there's also a link there for a type form where you can share more about your project, what you're working on, and we can be in touch to plan your talk with us. Thank you, everyone. Thank you for joining. Thank you for all the speakers that joined us today as well. And I hope to see you very soon.